All right, we are on week 3, day 4, the last homework video of this week. Okay, so let me look here. We have 20 questions in this one. The last one is quite a doozy. So let's get started with number 1. I want to solve for D, so I have to get D by itself. So I have to ask myself, what is 3 doing to D? Well, it's multiplying. So the opposite operation would be to divide. That will give me the required 1 here and leave me with just D. And 3 goes into 57 19 times. All right, again, I got to ask myself, what is the negative 8 doing to the P? Because I want the whole thing gone, even the negative. Okay, it's multiplying. The opposite operation is division. And you got to remember, because of that equal sign, you promise to be equal to both sides of this equation. So I have to do it to both sides. That will give me my required 1 for my property that I learned this week. And negative 8 divided into 88 is going to give me a negative 11. All right, I got to ask myself, what is the 9 doing to the n? And it is dividing it. That's what a fraction bar means. It's just a fancy division symbol. So to undo it, I got to multiply on both sides because I'm in a contract to be fair. Those cancel, leaving me with a 9. 9 times negative 63 is going to give me a negative number, and that negative number is going to be 567 negative. All right, what is the negative 9 doing to the y in this one? Well, it's dividing. So I've got to do the opposite, which is multiplication on both sides. Cancel, cancel, gives me a y. I'm going to have a negative because I have a positive and a negative, and 11 times 9 is 99. Got to ask myself what the negative 7 is doing to the x. It's multiplying, so we're going to divide it on both sides. Okay, giving me my required 1. Got to take that sign with it too. So negative 7, positive 1010. I know my answer is going to be negative. I'm going to divide the 7 into the 1010, and that is going to give me a negative 15. The 17 is multiplying the n, so I've got to divide in order to get that 1 I want. Okay, and it's really important. I can't stress it enough. It's really important that you know when you want to get a 1 and when you want to get a 0. Because when you get into matrices, into really complicated systems of equations, or even easy systems of equations in Algebra 2, you're going to have to know when you need a 1, when you need a 0. Let's start that foundation now, here. This is the equivalent building block to that big building block in Algebra 2. So make sure you really identify when you want to get a 1, when you want to get a 0. All right, 17 goes into 34 2 times. Okay, so there's the first 6 problems. Now we're going to go on starting with number 7. All right, so the negative 27 is dividing the n, so I'm going to multiply it to both sides. It's going to give me my 1 here, leaving me just with an n. 2 negatives are going to give me a positive number, so I know it's going to be positive, and in this case, it's going to be 54 when I multiply them. All right, so the 5 is dividing the t, which means I've got to multiply that bad boy. Cancel, cancel, or give me a 1. 30 multiplied by 5 is going to give me 150. All right, so we're going to skip over. All right, number 10. So I'm going to want to slide switch places. So I'm going to take this whole thing. I'm going to slide it this way. I'm going to take this whole thing. And I'm going to slide it this way. All right, this is confusing. Two symbols. So a plus and a negative make a minus. To get rid of it, I'm going to have to add 9. What I do to one side, got to do to the other. Gives me my 0. M equals 24. All right, so skip over 9. There was an error in the way the question was written. I already did number 10. Let me write it here so I can keep myself straight. So this one is actually number 11. All right, so 11 says -6 plus t equals -14. By now you should know I don't like this. So I'm actually going to flip-flop these terms. As long as I take the whole term and flip-flop, go bloop and bloop, the whole term, I don't change the question. All right, so the 6 is subtracting the t. So to be able to get my required 0 that I need in adding and subtracting, I need to add 6 to both sides. That's going to give me a big fat 0, which is going to leave me with t. -14 plus 6 is -8. All right, the 29 is subtracting the x, so in order to get the 0 I need to add 29 to both sides. That gives me a big fat 0, leaving me with x. All right, and this is going to give me, wait, did I do that wrong? 112? 110 red miles. Where'd you get that 2 from? Let's put another one in here. I think I can fit number 13. Ooh, this is another flip-floppy one. Okay, I don't like this. I want to put this here and this here. So it's going to read this. And then I still don't like it. I want to flip-flop these two terms. Okay, so it's going to be positive w minus 8 equals 20. Then 8 is being subtracted from w, so I need to add it to get my required 0. And I need to do that to both sides. 0, w equals 28. All right, we're making good time. Let's go on to number 14. Okay, so I don't like the way this is written. I'm going to flip-flop. So it's going to be w plus 797 and negative 987 here. The 797 is being added to w, so I need to subtract it to get my 0. That means, okay, get my 0. That means I'm going to add these and take the sign up, the negative sign, which is going to give me a negative 1,784. Let's try to fit 15 on here. All right, I want to flip-flop the sides because I don't like the way it's written. Got a double sign, need to fix that, okay? To get rid of a negative 8, I got to add an 8 because it's the opposite operation. And h is going to equal, after that turns to 0, 35. Five more questions. as you know, I don't like the way this is written, so I'm going to flip-flop the terms. Okay, just take their signs with them when you do it, so this one's still a positive. Okay, the 4 is adding to the t, so in order to get my 0, I got to subtract it from both sides. Okay. Alright, these signs are killing me. So I'm going to go ahead and change that first before I flip-flop the sides. Then I'm just going to flip-flop my sides because, as you know, I don't like the way this is written. Do you need to? No. No, if you can see it. And actually, I probably wouldn't when I'm doing math anymore. I just find it a lot more organized, a lot less negative and positive problems. Alright, so the 130 is adding to the p, so I am going to have to subtract it to get a 0. When I worked in college, I didn't show people the flip-flop. I just assumed them to know it. So if you get it, don't worry about the flip-flop. I just think it's easier for someone to keep their math straight. Alright, so 17 was negative 28. Now 18 is word problem. Olivia owns 43 CDs. This is 15 more than Angela. So what Angela owns is 43 minus 15, right? It's 50 because Olivia has 15 more than her. So Angela has 15 less than Olivia's. Okay? How many CDs does Angela own? I just wrote the equation. It's A equals 43 minus 15. And if I subtract those, get 28. Angela is 28. A bank charges an interest on money. It loans. Interest is sometimes a fixed amount of a loan. The expression is this, and this is pretty close to the actual compound interest expression. It's missing some things that I guess they are assuming to be 1, but here's our question. Give a total amount due for the loan in dollars of the interest rate I, where I is written as a decimal. Find the amount of the loan of 100. So that equals A. In our interest rate, you'll see there's 10%, which is 0.1. So this is evaluating an expression problem. I'm going to substitute these values in for my unknowns. Okay, so A will be 100, I will be 0.1. I do what's in the parentheses first, and then I do this, which means I just move that decimal place 2 places because I'm multiplying by 100, and then I have to put my decimal place back in. So if I invest $100, or if I get a loan for $100, I am going to have to pay back $110. That's how that works. Can the expression 2x and x plus 2 ever have the same value? If so, what can it be? Alright, so I need to kind of do a table because this is one of the ways that we express math, right? And a table expresses math by letting us see values. So I'm going to pick different values for x. I'm going to plug them into my expression 2x, and I'm going to plug them into x plus 2 and find the results. So the numbers that I'm going to pick is 0, 1, 2, negative 2. I'm going to test a good different amount of numbers to see what happens. Now I got to put these in. Alright, I'm going to put 0 in for this one. 2 times 0 is 0. And I'm going to put 0 in for this one. 0 plus 2 is 2. Those are not the same. Okay? So now I'm going to put 1 in for this one, and I'm going to get 2. And when I put 1 into this one, the answer is 3. So my answer is 2 and 3. That is not the same. Now to put 2's in. 2 times 2 is 4. 2 plus 2 is also 4. So it's the same in this situation, okay? Let's try the last one. I'm going to try a -1. That's going to give me a -2. And if I put a -1 in here, I'm going to get a 1. Just out of curiosity, I want to see what happens when I put a -2 in. So let's do another one. It's going to become a -4 here. But look what happens when I put a -2 in here. It's 0, okay? All right, so the only time is this one. So why is that so? Well, first thing is first. I've run out of room. So let me make some more room. Well, multiplication is just repetitive addition, okay? So when I say 2 times 2 and I say 2 plus 2, they are the same thing. Because multiplication is just repetitive addition, and this says I have 2 2's being added together. Guess what this says? You have 2 2's being added together. So it just so happened at this one point they both were saying the same exact thing, okay? So that only works because there is a 2 coefficient and a 2 constant in both terms. If I change it to 2x and x plus 3, then we're never going to have anything the same, okay? It's only because one represents the derivative of the other, the derived form of the other. They're both actually the same. Multiplication and addition are the same in the right context, and this is the right context. All right, I hope that it made sense. Keep studying, and I'll see you next week.